Hello all, happy evening to all. Are you guys able to hear my voice? If my voice is clear, if my voice is clear, just put in S in chat box. Are you guys able to see my screen? If everything fine means just put S in chat box. Today we are going to see about MAX10 FPGA board only. This is a FPGA board we are going to use in MASTERCLASS. This is the vendor of this FPGA board is Intel Altera, and it is tested and developed by a Pantech only. All the PCBs and all the I/O interfaces and Ethernet, all the planned and fixed by Pantech only. We are going to using this FPGA in the whole MASTERCLASS. This is a main IC of the FPGA named as MAX10, but you can't see clearly in this picture. The name of the FPGA is, every FPGA having a unique name ID like this only, 10M50 DAF 484C7G. In this name, each and every letter have a specific identification. I will show you what are the identification the model name having. Here this is a specification of the each letter in the model name. Like firstly we in the our FPGA board having 10M. 10M means it's a family signature name. Like MAX10 is a family name. It is signature name of the FPGA. And we having the 50. 50 means how much of the logical elements FPGA having. Like here is a 60. 60 means 16 means like 16k logical elements that FPGA having. That particular FPGA having. Our FPGA board having 50, like 50k logical elements on the IC, FPGA IC. And coming to next, DA means feature options. Like SC is a single supply, it stands for single supply. SA is a single supply and analog and flash features. SL is a single supply with the flash features with RSU options. And DC means dual supply but compact features only. Like DA is a dual supply and you can access analog and flash features with RSU option. RSU option is nothing but remote system upgrade. You can access a FPGA board by remote system via the UART interface, UART serial communication. Our FPGA having the DA means dual supply analog and flash features with RSU. Our FPGA we can access the analog and flash features with the RSU options. We can also give a dual supply for the FPGA, like dual supply voltage like 5 volts. One is based on the power supply cable, another one is based on USB power supply. I will show you in the FPGA. This is a input for power supply, first power supply, and you can give also input from this USB port for the FPGA. That's why it having the dual power supply. And then UV stands for package type. Like every FPGA having a package type. UV is our FPGA board having F. We can see what is a F. F means fine line BGA. In this every letters in the model name, it's very important while dumping the code into FPGA. Intel Cortex Prime tool, yesterday we seen that the tool asking the correct model name for the FPGA, so that we have to ensure that we have to give correct model name for the FPGA. So each and every letters must be we have to listen, see the careful in the while dumping the FPGA. And another one is a 484. Our FPGA also having a 484. It means FPGA having the 484 pin outs and pin IO pins, and our FPGA having C stands for operating temperature. Like C is a commercial. If the feature of FPGA model I am having high, it's industrial purpose only, so that we can justify that. And is 7 for speed. In our FPGA board having 7 in the model name, it means it refers to 7. FPGA fabric speed grade, like 6, 7. There is a various type of speed grade in FPGA. It is 7 is refers to that what are the speed having the FPGA. And finally G is a what is the role of the operational suffix on of the FPGA. Like G is, it refers to ROHX6. It indicates a specific device options for the shipment methods. Like if the FPGA board having ES is comes under the engineering samples. If the FPGA having the last letter P, it comes under the leaded package. These are the name of the FPGA. We first have to know that what kind of name, what kind of family our FPGA having. So that I am telling to you, it is very important for dumping the code into FPGA while using the Intel Cortex Prime tool. Let's coming to the FPGA. MAX10 devices are a single chip, non-volatile, low cost, programmable logic devices to integrate the optimal set of system components. Our FPGA having the single chip and non-volatile memory. It means we can store the memory, store the code or store the data in FPGA, and we can access also after the switching from off to on condition, so that it is a non-volatile nature. It is a best feature of our MAX10 FPGA. And then let's see highlights of the Intel MAX10 devices included. It has internally stored dual configuration flash, user flash memory, instant on support, integrated analog to digital converter, and single chip noise to support core software for support. It means our FPGA board having the dual configuration memory. Basically, Intel MAX10 having the 3 types of memory, that are CFM, UFM, and secondary memory like SRAM, STRAM. Like UFM, CFM are built into the FPGA only. Like SRAM only we can see in the out of the FPGA on the PCB, but UFM and CFM are located in the FPGA only, inside the FPGA. Both are the non-volatile in nature. We can access the FPGA at any time while after the off condition. We don't want to flash the code again to again. And our MAX10 FPGA having the integrated analog to digital converter, so that we won't write for analog to digital converter code in Verilog file. We can access the IO pins of the analog to digital converter. By using the pins, we can get analog. We can give analog input and get analog digital output. By using the pins only, we won't write for the Verilog code to analog to digital converter. And then let's see key advantage of the MAX10 FPGA. The main advantage of the FPGA is simple and fast configuration, flexibility and integration, low power, and our MAX10 FPGA lifespan is 20 years, up to 20 years. And high design tools. A simple and fast configuration by means our FPGA having the non-volatile memory, so that we can load the code to FPGA within 10 milliseconds. And flexibility and integration. Our FPGA having the PLD logic and RAM and flash memory, digital signal processing, ADC, and PLL. PLL is nothing but phase locked loop, It is used to create a required frequency by using the clock oscillator in the FPGA in the PCB. And also n number of IO pins, like 484 pins. It's not simple. It is a huge amount of IO pins in the FPGA. So it is also one of the flexibility. We can use IO pins for all the complex logic circuits, and small in size, like 3mm class 3mm only it having, so that it is a flexibility and integration. And our lifespan of the FPGA is 20 years. If you maintain a correct temperature, you can access our FPGA up to 10-20 years. And we'll see core architecture of the FPGA MAX10. Our FPGA having the 4 input lookup table. Yesterday we seen that what is lookup table and what are the functionalities it having, and single register logic elements. And logic elements are arranged in logic array block, like LAB. And embedded RAM and user flash memory, it is a main feature of the core architecture. Because of lots of FPGA don't having the user flash memory, MAX10 series only having the user flash memory. And clock and PLLs, I already said no. PLL means phase locked loop. It is used for to create a required clock frequency by using the FPGA oscillator, clock oscillator. And it having the embedded multiplayer blocks and a general purpose IO pins. The internal memory blocks are nothing but RAM and dual port FIFO functions. It having the 9 KB of the memory blocks in the FPGA. And it is time for converting your masterclass to internship. If you guys are interested only, if you guys are interested in the masterclass, you can convert the masterclass into 1 month internship or internship of VLSI design. We are providing the benefits of the internship is all 30 days recording sessions, all 30 days presentations, and exclusive projects and codes you can download also, and a VIP community group for your doubt clearing and internship updates. And you will get a internship confirmation letter from IETE, and you will get access for 90 days of LMS course access, and we will give you assignments and tasks for your knowledge purpose only. And we will containing the weekly live sessions for doubt clearing, and a resume building and mock sessions also we provided in benefits of internship. And you will get the internship and the participation certificate of the 1 month internship. Our regular cost is for particular VLSI design course is 1,999, but in the masterclass period we will give you discount up to 800, like 799 only. If you want to join 1 month internship of VLSI design, use the registration link on chat box. Our organizer will give the post chat box. Use that one, and you can join our internship, 1 month internship. This offer is only for up to 8/2/2004. It means next month too only. It is limited time offer. Please avail it. And then coming to, I already said no. One type of the memory is user flash memory. Our FPGA having in the UFM, it is kind of memory inside the FPGA. It is high speed operating frequency, large memory size, high data retention, and multiple interface operation. It means like multiple interface operation means you can access the remote. I already said no. Our FPGA having the RSU, like remote system upgrade. The remote system upgrade is based on UFM memory only. There is separate code in the IP for the RSU. You will access the remote access by using the UFM memory only. Because of our SRAM and DRAM are the volatile in nature, so our code we flash the code will be gone when the FPGA is off. So that UFM is very needed for RSU, remote system upgrade. And then coming to embedded multiple blocks, our FPGA having the multiplayer modes like 18x8 and 9x8 and cascadable blocks enabling the creating the filters and arithmetic functions and image processing pipelines. And our FPGA having the analog to digital converter in the board only. We can give the 20 channel input as per the analog input, and we can get also 17 channel output of the ADC converter. The ADC converter having the cumulative speed up to 1 million samples per second. We can get the speed of digital output by 1 million samples per second. And also ADC having the integrated temperature sensing capability. And our FPGA having the clock networks. There are two kinds of clock networks: global clock support and high speed frequency in the clock network. All the FPGA having the clock oscillator. Clock oscillator is nothing but used for creating the clock high frequency clock. By using the clock oscillator, we get the required clock frequency. Our FPGA having the built-in internal ring oscillator. It will also create a clock frequency. The circuit of the ring oscillator looks like this only. It is fully based on the CMOS inverter and are giving connection like this only. Like this is input for the first CMOS and give output for the another CMOS as the input, and out of this CMOS and given to the input for another CMOS, and last CMOS having the output and it will give to the first CMOS input. This is called a ring oscillator. We can get required frequency by using this circuit because of there is a delay for there is a delay from one CMOS to another CMOS transaction. So by using this circuit we can get required frequency. Let's see what is mean by PLL, phase locked loop. It is used for analog based low jitter. Low jitter is nothing but noise in the clock frequency, and also it is used to high precious clock synthesis, clock delay compensation, zero delays of buffering, and multiple output taps. Zero delay buffering means our in our FPGA there is a separate block for PLL, phase locked loop. By the process of the phase locked loop is to create a clock frequency using the voltage controller VCO, like VCO, it means voltage control oscillator. And the VCO uses the reference clock from the FPGA clock oscillator and comparing the both clock frequencies bandwidth and creating the error free or noise free clock frequencies. The function of the PLL is to creating the required frequency and noise free clock pulses. This is the main function of the PLL, to create the noise free and required clock frequency of the oscillator from the oscillator. And our FPGA board having the general purpose pins like 484 pins, and we can transfer the data from the pins up to 720 Mbps. We can send and receive that data from IO pins. And then already said no, our FPGA board having a separate SRAM DRAM. It is called as external memory interface. Our external memory interface supports up to 600 Mbps speed while transmitting and receiving the data. The RAMs mostly a MAX10 FPGA having the DDR3 memory, DDR3L memory, or DDR2 memory, or LPA DDR2 memory. Our FPGA board having MAX10, that particular model series of FPGA board having DDR3 memory only. It is fully based on SRAM functionalities. It is a volatile in nature. if you dump the code on DDR3 memory, while you switch off the FPGA, our whatever the data you store in the memory, it will erasable. So that, but if you want to see particular output at the time only, you can use this external memory interface. Because of we can't use that code for long period of the FPGA. If you want to see just you can see, if you want just see output for the particular code, you can use this memory. It is useful for fast execution and compilation of in the FPGA. User and the other FPGA, other memory like UFM, CFM, it will taking time to dump the code into FPGA. But using the DDR3 memory or SRAM memory, you can easily dump the code into FPGA. It take only small amount of time. And then configuration, we can configure the FPGA by using the internal configuration JTAG cable. Most of FPGA is based on JTAG only. We can, by only using of JTAG, we can configure the FPGA. Our Intel MAX10 is only based on only configured by the JTAG only. Like Spartan or other FPGAs, we can configure by using the USB cable. But in Intel Altera MAX10 FPGA, we can configurable only by using JTAG cable. And in the configuration, the flash memory data retention of the up to 20 years. If you dump the code in UFM or CFM, and the code won't erase up to 20 years. If you maintain a correct temperature like 85 degrees Celsius, you can access the code of up to 20 years, like the FPGA lifetime of the time. And MAX10 FPGA is a flexible power supply schemes. Because of our FPGA having a two power supply options, like one is a main power supply, and another one is you can give power supply by using the USB cable. And let's coming to the UFM, like a user flash memory. It is a black in the Intel MAX10 device, stores a non-volatile informations. And also UFM provides an ideal storage solution that you can access by using the Avalon memory mapped. It is on IP core. Using the Intel Cortex Prime, we can add the IP core on to the FPGA. There is a lot of interface protocol or IP16 devices for MAX10 devices. You can, if you want to access the Ethernet by using the MAX10, you have to add a Ethernet IP from the Intel Cortex Prime tool to FPGA. We have to dump the IP to FPGA. Then only you can access the Ethernet on FPGA. There is a lot of IPs in the FPGA, like only for MAX10 devices, like dual configuration memory. Like UFM also used based on IPs only, IP cores. Let's see the features of the UFM, user flash memory. The UFM counts at least 10,000 programs and erasing per cycles. And the data retention of the UFM is up to 20 years also. I already said no. And the maximum operating frequency is varying from different devices. Like if you give the serial interface of the FPGA, our FPGA is MAX10 50. It having the 4.81 megahertz parallel rate. And if you give the interface like parallel interface, you will get the MAX10 here's MAX10, you will get 116 megahertz frequency. And the data length of the FPGA is 32 bits length in parallel. And coming to the clocking and the PLLs, our FPGA would having the separate global clock oscillator and also PLL. inbuilt PLL. So much of many FPGA devices don't have PLLs in the FPGA, but our MAX10 FPGA having the PLL inside the FPGA, we can by using the PLL we can get required clock frequency. Like our global clock oscillator will give the output of 160 megahertz only by use, but we can increase the clock frequency by using the phase locked loop. This is one circuit. It will it is that doing a separate operation to create the required frequency. We will see it in upcoming slides. This is a circuit for the PL, phase locked loop. It is a reference. The input of the circuit is reference signal. It will comes by it will output of the our global oscillator, like main oscillator, and there is another oscillator, VCO. VCO stands for voltage control oscillator. It will also give some clock pulses from like 32. We have to fix how much of the clock pulses how much of clock frequency we want from the VCO, and then our requirement based on it will give. Like if you want 36 megahertz of the clock frequency of a VCO output, it will give 36 megahertz, and and also it having a low pass filter and a clock divider. In this block doing of the comparing of outputs like VCO outputs and input oscillator inputs, both of output and inputs clocks are matched and giving the required output, like and passing to the low pass filter, and we can get output from this VCO output. It means it will give the 36 megahertz, and in this block it will divide by 3, like that 12 megahertz or different phases. In this block, the purpose of this block is matching the phases of the output of the clocks, like VCO output clock frequency and also reference signal frequencies. By matching these phases, we can get the required frequency in the output of VCO. And let's see, high precision and low jitter PLLs offer the following features. Like our FPGA board having PLLs, it gives the features like redundancy, reduction in the number of oscillator and required on the board, and reduction in the device. Clock pins show a multiple frequency synthesis for a single reference clock sources, and also it gives frequency synthesis on chip, clock deskew, and jitter attenuation. Jitter attenuation nothing but noise attenuation. Noise is like a power loss or a clock. Some clocks having the noise is noise, so that by if you want to clear the noise by using the PLL, you can attain that. And a zero delay buffer, counter reconfiguration, bandwidth, programmable output duty cycle, PLL cascading, reference clock switching, and driving a analog to digital block. These are the main features of the PLL. And this is the time for you can convert the internship to masterclass only if you guys are interested only. We can give the benefits of internship are all the 30 days recording sessions, all the 30 days presentations. We will give exclusive projects and VIP community group for your doubt clearing and internships. And also we will give you internship confirmation letter from IETE, and also you can access a 90 days LMS course, and we will give assignments and tasks, and we containing the weekly live sessions for your doubt clearing and internship updates also, and we will give how to build a resume, and we will conducting some mock tests for your interview purpose, and we will give you internship and participation certificate. Our regular fee is for this 1 month internship of VLSI design is 1999. in this masterclass period you will get 799 only. If you want this, you can buy the course by using the registration link on chat box. Our organizer will post a chat box, and it is a limited time for offer up to 2/8/2024. And coming to the dual configuration, it's like our FPGA having the dual configuration, like this is a kind of memory. It having the two images, like image 1, image 2, CFM1, CMF2. It means you can dump the code in the two parts of the memory in the FPGA. Like MAX10 FPGA having the CFM, configurable memory. If you want to dump the code in image 1 memory by using the config cell pin. Every FPGA having a separate switch for that. By using the switch, we can we can dump the code on CFM1 or CFM2. It's like a image only. And this is for today only. And tomorrow we will see about digital electronics basics like encoder, decoder, and so on. Thank you for listening. Thank you guys. We will see tomorrow.